The key thing in this section is that we can treat square roots, or we can treat roots like variables. Like if we have just x, 2x plus 3x is 5x. Well, 2 times the square root of something plus 3 times the square root of the same thing is just going to be 5 square roots of that thing. You'll see in a second. So for example, 4x plus 2x, what's that if I simplify it? It's 6x. 4x plus 2x is 6x. We know how to do that. Those are like terms. 4 square root 2 plus 2 square root 2. If we treat the square root 2 like a variable, we can do exactly the same thing. So what we have here looks like in our left hand we have 4 square roots of 2. Like I have 4 little cards and they have the square root of 2 written on them. There's 4 of them in my hand. In my right hand I have 2 cards that have the square root of 2 written on them. That's what this basically says, 2 root 2's. So I have 4 root 2's plus 2 root 2's. If I put them together I have 6 root 2's. So I write 6 square root 2. We're basically treating those radicals, that square root symbol with the things underneath, like a variable. If the terms are like terms, meaning if they have exactly the same thing under the square root, then you can combine them. If this was a square root 3, if this was actually 2 square root 3, these would no longer be like terms and you can't combine them anymore. That would be like having 4x plus 2y. We know we can't combine those. Those are not like terms. Neither would these be like terms if this was a different number. The number under the root when you combine them stays the same. Just like the x stays x after you combine like terms, the number under the root stays exactly the same as well. And that's the last point on this page. All right, so let's try some examples here. We have 5 root 2's plus 7 root 2's minus 6 root 2's. 5 plus 7 is 12, so that would be 12 root 2 minus 6 root 2. And 12 root 2 minus 6 root 2 is 6 root 2. Savannah. For the second one, 10 square root 7 plus 5 square root 11 plus 4 square root 7 minus 6 square root 11. Do we have any like terms we can combine there? The root 7's are like terms. And these guys, the root 11's, are like terms. So we can combine each of those. 10 root 7 plus 4 root 7 is 14 root 7. 5 root 11 minus 6 root 11 gives us minus the square root of 11, minus 1 root 11. Now, can we combine these in some way? Nope, these are different numbers under the square root, so we have to leave them separate. This is our answer right here. Go ahead and try the other two. These are all like terms here. The square root of 2's in each of those terms are like terms, so we get 2 square root 2. And not all like terms there, but we can still combine some like terms. What do we get? 15 square root 3 minus 11 square root 3. Yep, 4 root 3. And then negative 14 root 5 plus 6 root 5 would be negative 8 square root 5. Could you have written those in a different order? Negative 8 square root 5 plus 4 root 3? Yes. So it just depends on how you do it, how you write it down. If they're in a different order, as long as your signs are good, you're still good. Okay, how about the next one? 2 root 18 plus 2 root 32 plus root 72. Do we have any like terms there? Not right now, we don't. But in the last section, what did we learn how to do?
No.
Yes.
No.
It's true. Simplify your roots and then see if they have like terms after that. It's not that hard, actually. Is there a perfect square that goes into 18? Yeah. 9 times 2. So we have a 2 out front, square root 9 times 2. I can take the square root of 9 and I get 3. So that's 2 times 3, which is 6 root 2. Now, I'm going to give you a hint on these. In Algebra 1, most of the time, if we're asking you to do a problem that looks like this, chances are pretty good you're going to wind up with like terms. So that means you're probably going to wind up with a square root 2 in each one of these terms. So think to yourself, 32 divided by what is 16? Sorry, 32 divided by 2 is what? Okay, is 16 a perfect square? Yeah, so if you keep that hint in mind, it helps you find that perfect square pretty quickly once you find the first one. So this will be plus 2 square root what? The biggest perfect square is 16 times 2, and that reduces down to plus. Square root of 16 is 4. 4 times 2 is 8. Square root 2. And now, again, we have that square root 2, so I'm guessing probably this is going to wind up being something square root 2. So 72 divided by 2 is 36. Is 36 a perfect square? Yep. So makes it very easy. Plus square root 36 times 2. The square root of 36 is 6. So I have plus 6 square root 2. Now do I have like terms to combine? Yeah. So what do we get when we combine those? 6 plus 8 plus 6 is 20 square root 2. There's your answer. That's not too much. You guys have done problems that were way longer than that, and you didn't complain about them. In fact, some people said they were easy. You did. Not these, but some other problem that was way longer than this. Okay, how about, let's see. Let's do the second one together also. What should I do first on this? All right, biggest perfect square that goes in 54 is 9, so I have 4 square root 9 times 6. Now what? So the square root of 9 is 3. 4 times 3 is 12. Square root 6. Now what? So plus 2 square root, and then the biggest perfect square that goes into 24 is 4 times 6. 4 times 6. Square root of 4 is 2. 2 times 2 is 4. And I'm left with square root 6. And then we add them together and we have 16 square root 6. Notice again, we wound up with 6 here, 6 here. So chances are pretty good we're going to have like terms to combine afterwards. Go ahead and try the other two. For the third one, 4 square root 12. What do we do? 4 square root 4 times 3. The biggest perfect square that goes into 12 is 4, so 4 times 3 is what 12 splits into. And now we do what? Before we have 4 times 2, how do we get to 2? The square root of 4 is 2, so now we have 4 times 2, which is 8. Square root 3. All right, up here we have minus the 6 square root. Biggest perfect square that goes into 48 is 24 is not a perfect square. 16 is, though. Remember that trick that I showed you? We got this one. We left with the square root of 3. So take 48 and divide it by 3 and see what you get. If you get an integer, then see if that's a perfect square. If you divide 48 by 3, you get 16. 16 is a perfect square. So this thing splits into 16 times 3. And now we have minus, the square root of 16 is 4. 4 times 6 is 24. Square root 3. Yep, so now you do 8 minus 24, which is negative 16. Square root 3, and you're done. Okay, the second one had 3 square roots on it. A little bit of a bummer there, but it's no big deal. What's the biggest perfect square that goes into 24? 4 times 6. Okay, so we have the square root of 4 times 6, which simplifies to 2 root 6. All right, so now I have this square root 6 sitting here. I'm going to see if there's a perfect square times 6 that gives me 54. So do 9 divided by 6, or sorry, 54 divided by 6, which is, I keep getting a little ahead of myself. So we have minus square root 9 times 6, which turns into minus 3 root 6. Okay, so we have root 6, root 6. Let's try dividing 48 by 6 here. What do we get? 8. Is 8 a perfect square? No, it's not. So we're going to simplify this with 16 times 3. So square root 16 times 3. So this is plus 4 root 3. Yep, now you combine like terms. Is it okay that we have a square root 6, square root 6, square root 3 here? Yeah, that's going to be fine. We just won't combine everything. We'll combine the square root 6 ones though. So you have 2 minus 3, which is negative 1, square root 6 plus 4 square root 3. Now the answer in the back of the book, if this was a book problem, would have written this in a different order, because generally if we can write less stuff, then we'll rewrite the answer writing less stuff. So probably my guess is the book would put 4 root 3 first, and then minus 1 square root 6. That would be the answer you'd see in the back. So that would be perfect. So we can also use the distributive property and FOIL methods with radicals. Just follow the usual procedure. With the distributive property, you distribute. With FOIL, you do the first, outer, inner, and last terms. And then simplify things down. So you're going to FOIL and distribute, but also use the rules for simplifying radicals once you're done. So there's a couple extra steps here sometimes. All right, on this one, what are we doing? This is just distributing. So I'm going to take that square root 10 and distribute it to both of those terms. What is the square root of 10 times the square root of 6? Square root of 60. Plus, what is the square root of 10 times 3? 3 root 10. Remember the rule from last time. What's outside the square root multiplies with what's outside the square root. Things inside the square root do multiply together. This is outside, this is inside. They can't combine. This is inside Vegas, this is not. So it has to stay outside. All right, now what do we do? Simplify. Yeah, we have to, if there's like terms, combine them. We have to simplify our square roots also, though. So, is there a perfect square that goes into 60? Just start going through the list. 1, 4, 9, 2, and 30, but neither of those are perfect squares. So just start going through the list. Does 1, well 1 doesn't count. Does 4 go into 60? 4 and 15. If you look at 15, are there any other perfect squares in 15? No, so it's 4 times 15. So this becomes the square root of 4 times 15, which is 2 root 15. Now we have plus 3 root 10. Is there a perfect square that goes into 10? Nope, there isn't. So we can't simplify that second one. So we just write it down, and that's our answer. Yeah, this one is going to be a FOIL problem. We have 2 terms times 2 terms. So just FOIL it. Be very careful as you're going, because you're going to have a lot of places that you can make mistakes, more than when you're just working with variables. So we have the square root of 6 times the square root of 6, which is the square root of 36, which we do know is 6, but we're going to write down the square root of 36 anyway. So we did that one, and now we have O, the outer, the square root of 18, so plus square root 18. And then we have the inner, okay, and then finally the last. Okay, so now that we've FOILed, we just want to start simplifying things. Can we simplify the square root of 36? Yeah, it just turns into 6. Now notice that we have like terms here. We have a square root of 18 and a square root of 18. Can we combine those? Yep, so let's combine them. What do we get? We have a positive 1 minus 2, which is negative 1 square root 18. So I'm going to write minus square root 18. Minus 1 square root 18. Now we have this minus 2 square root 9. Can we simplify square root 9? Yeah, what is it? 3. So what does this turn into? minus 6. 6 minus 6 is 0. So this guy and this guy disappear, and now we have just negative square root 18. Does the square root of 18 simplify? Yes, it does. 9 times 2. So now we have negative square root 9 times 2. And what's our answer going to be? Nice. So, you FOIL, which you know how to do. You multiply things inside square roots together, which you know how to do. You combine like terms, which you know how to do. You simplify things down, which you know how to do. And then finally, when you get to your answer, you're done. So you know how to do all of this stuff. We're just starting to put a lot of things together all at once to make the problem a little bit more complicated. Now, what is this notation right here telling me? Not square root. Can I distribute the square in? Is that something I can do? No. I've heard a couple people already say this. This actually, yes, is a FOIL problem. This square here means multiply this thing times itself. So remember that, because this sort of thing pops up on the homework. Make sure that you're multiplying. That's actually still a FOIL problem. So now once we FOIL it, let's talk our way through this. FOIL this thing. So square root 121. Two square root 11. Minus another 2 square root 11. Yeah, negative 2 times negative 2 is positive 4, so plus 4. All right, square root of 121, does that simplify? 11. We have like terms right here. What does that become? Minus 4 square root 11. And then this guy, plus 4. All right, next line down. What can we simplify now? 11 plus 4 is 15. Minus 4 square root 11. Now what? You're done. The square root of 11 can't be simplified. These are not like terms, so we can't add them together. That's it. You're done. So that's the idea. This is like the big thing in this section. Go ahead and do the other two. Same way. Distributive property here, FOIL here. Just be very careful as you're going. What should I do first? On the left. So, okay, we have the square root of 12 plus 5 root 2. Next, somebody else. Okay, square root of 12 turns into the square root of 3 times 4, or 4 times 3, plus 5 root 2. Square root of 4 is 2 root 3 plus 5 root 2. And that's the answer. We can't combine those. Okay, second problem. Somebody else, please.
Thanks.
I want other people to talk. FOIL, what's my first move? Okay, so first terms, negative square root of 6 times 4 root 3. 4 root 18. Good. And outer terms. That's a positive 3 square root. 6 times 6 is 36. Minus 8 square root 9. Minus 6 square root 18. All right. Now what can we do? All right, combine like terms. Do we have any like terms? Where? 4 square root 18 minus 6 square root 18 gives me negative 2 square root 18. All right, so these two guys are gone. Now we have these two middle guys. Simplify them. How do I simplify this one? So the square root of 36 is 6 times 3 is 18, so I have plus 18. And what does this one turn into? Good, minus 24. The square root of 9 is 3, and 3 times negative 8 is negative 24. Anything else? Combine like terms. So we have negative 2 square root 18 minus 6. And anything else to do? The square root of 18 does have a perfect square in it. What is it? 9 times 2. So this turns into minus 2. Square root 9 times 2. And then outside minus 6. So my final answer is going to be there you go.